Alright, this lesson is part 2 of section 8.4. Today we're going to be graphing exponential decay functions. So yesterday we worked on growth functions. Today we're going to be focusing on exponential decay functions. Now our very first example is actually a growth example, an exponential growth example. We did this exact same problem yesterday in the notes, so I'm going to go through this pretty quickly. Remember, the first thing that we want to do is create our table values. So they're going to go from -2 all the way to 3. And then we're going to plug in these x values in for the x here. And it's not multiplication. Remember, this is you're exponentiating, so it's 3 to the -2nd power. So 3 to the -2nd power is the same as 1 over 3 to the 2nd power, because we want to move that unhappy exponent down in the basement. And we end up with 1/9 when we evaluate that in a calculator. So we have the coordinate -2, 1/9. When I plug in -1, it's very similar. We're going to move that whole base down to the basement. We get 1 over 3 to the first, which means 1/3. And we end up with the coordinates -1, 1/3. I'm going to pause the video right now. What I would like you to do as well is pause the video and then fill out the rest of this table, and then check your answers and make sure they're the same as mine. Okay, so go ahead and pause. Okay, now I'm also going to plot the points. So I've just finished off the table. Please double check that your coordinates are all correct. Now we're going to plot a couple of the points together. Remember, when you graph -2, 1/9, I want to go left 2 and then up just a little bit above that x-axis to kind of show that this is 1/9 right here. So I'm just estimating right there. Then when I do -1, 1/3, I go to -1, and this should be a little bit above my other point because 1/3 is a little bit bigger than 1/9. And then I'm going to go ahead and just plot the rest of these. Okay, so go ahead, please pause the video and plot the rest of those. Okay, so here you go. I went ahead and I plotted the rest of those points, and then I connected those points with a smooth curve. Now notice I do have a point that's off the graph, 327, so obviously we can't graph it exactly where it's supposed to be, but I just kind of estimated and showed that it would be off the graph, and I labeled that point. Okay, now I want you to look at the shape of this graph, and then we're going to take a look at a very similar function. Obviously it's a little different, but now we have 1/3 to the x power. So instead of 3 to the x, we're going to be evaluating 1/3 to the x power. Okay? Alright, so we're going to start with our table of values from -2 all the way to 3. And again, I plug in these values, so I'd have 1/3 to the -2nd power. And when I evaluate that, I'd have to distribute this to both the top and to the bottom. Right? So I have 1 to the -2nd power over 3 to the -2nd power. Now we know that both of these are unhappy exponents, so both of them are going to flip. This 1 to the -2nd power is now going to move to the basement, and this 3 to the -2nd power is now going to move upstairs. Oops, I should have been writing that as a positive too. And now we just evaluate. So 3 squared is 9. 1 squared is still 1, so I could write over 1 if I want, or I could just keep it as just 9. Okay, so our very first coordinate here is actually -2, 9. Okay, let's fill out the next value. When I plug in -1 in for the x, I would end up with 1/3 to the -1st power. And again, I'm going to distribute that -1st power here to both the top and the bottom, the numerator and denominator, to get 1 to the -1st over 3 to the -1st. Once again, both of these are unhappy. They're negative, right? So we're going to move them from, they're going to switch sides of the fraction. So we have the 1 to the -1st power now becomes 1 to the 1st power on the bottom, and 3 to the -1st power moves up top to become 3 to the 1st. And if we evaluate that, 3 to the 1st is still just 3, and then 1 to the 1st is still 1. So we could, again, write over 1 if we want, or just keep it 3, which is what I'm going to do. So now we have the coordinates, -1, 3. Okay, the next couple are going to be a little bit easier because we don't have to do any switching on the fraction bar here. We have 1/3 to the 0 power. Again, anything to the 0 power, that's always going to equal 1. So we have the coordinate 0, 1. Now when we plug in 1, we have 1/3 to the 1st power. If we distributed this 1st power here to both those, it's actually not going to change either number, so we just end up with 1/3. So we have the coordinate 1, 1/3. This is my x value, this is my y value. Finally, the last couple here, if we take 1/3, we square that, we take it to the 2nd power, we have to make sure again that we distribute it to the top and to the bottom. Now when we distribute that to the top, 1 squared is going to just stay 1, And then 3 squared becomes 9. So I have the point 2 comma 1/9. When I plug in 3, I have 1/3 to the third power. Again, we distribute that 1 to both, or to the 3, I'm sorry, to both the numerator and the denominator. So I have 1 cubed and 3 cubed in the denominator. 1 cubed is staying 1. 3 cubed is 27. So I have the coordinate here, 3 comma 1/27. Okay, now we're going to go ahead and start plotting these points. Okay, let's start the very first point here, -2, 9. So if I graph -2, 9, that's nice right here, right on the corner of a box. Same thing with -1, 3. So -1, 3 is right here. 0, 1, right there. Now they get into some fractions here, but again, it's the same idea as we've been doing. 1 1/3 is going to be about right here. Okay, so I go to 1 on the x value, and then for the y value, I'm just going to move up a little bit, about 1/3 of the way between 0 and 1. When I do 2 1/9, this time I want to be a little bit lower than that last point that I just graphed. I know it's hard to do, but you just want to be a little bit lower because you know that 1/9 is smaller than 1/3. And then when you do the last point, 3 1/27, again, you're going to go to 3 on the x-axis and then go up even smaller amount than the last point you just did, because 1/27 is even smaller than 1/9. Now, if I look at these points and I want to connect these with a smooth curve here, the graph actually looks a little bit different than the graph we just worked on above, right? It's kind of like it's been reflected. If you imagine this being a mirror right here, it's sort of like it's just been reflected over that mirror, okay? So it's been flipped, and that's the graph of an exponential decay function. Now we're going to practice this a lot more, but that's the general shape of an exponential decay. So let's write that in. And tomorrow we'll get a whole lot more practice with more decay graphs, okay? Good job. I'll see you in class tomorrow.